The summer sun blazed over Brandenburg, the air shimmering with heat waves, as Hauptmann Werner Tierfelder strode toward the lone fighter parked on Rechlin's concrete apron. It was July 20th, 1944, a day that would etch itself into the memory of anyone standing there. And yet, the aircraft before him seemed almost impossible to exist in this place, in this time. Its olive drab paint was scratched and sun-faded. Someone had crudely brushed Luftwaffe crosses over the fading remnants of American stars, a desperate attempt at disguise. But paint could not mask the truth. This machine was something wholly foreign, a puzzle wrapped in aluminum. Dear friends, if this video has reached you, it's not by chance. Right now, click the subscribe button and the notification bell. Write a number from 1 to 5 in the comments. I will personally respond to the first 50 comments, and make sure to watch the video until the end. Tierfelder circled the P-51 Mustang with deliberate caution, like a predator sizing up unfamiliar prey, or perhaps like prey calculating the moves of a predator. The fuselage was narrower than he had anticipated, almost delicate when compared to the sturdy Focke-Wulfs he knew intimately. His hand traced the leading edge of the wing, sliding over the smooth laminar flow surface, a marvel German engineers had studied, but never fully reproduced in mass production. The aluminum felt astonishingly thin, almost fragile. American philosophy, he thought. Build it light, build it fast, and build 10,000 of them. For 4 long years, Werner Tierfelder had served the Luftwaffe, first as a fighter pilot intercepting RAF bombers over the Ruhr, then as a test pilot at this secretive northern facility outside Berlin. He had flown captured Soviet Yaks machines, more akin to tractors with wings. He had tested British Spitfires, graceful in the air but embarrassingly short on fuel. He had evaluated the American P-47 Thunderbolt, a massive radial engine fighter nicknamed the Jug by German pilots, powerful in dives but cumbersome in sustained dogfights. And yet this Mustang was different. Reports from the Western Front had grown increasingly urgent, tinged with alarm. Luftwaffe pilots were encountering a fighter that defied the established laws of aviation. According to German aerodynamic theory, a long-range escort fighter simply shouldn't exist. The fuel required for such range should render it too heavy to maneuver effectively. And yet, the Americans were escorting their bomber formations all the way to Berlin and back. And the fighter they used for that mission? It was outmatching Germany's finest interceptors. Just 2 weeks earlier, the Mustang had been forced down near Aachen. Its Packard-built Merlin engine had sputtered and coughed, the pilot reporting fuel contamination. He belly-landed in a field. The aircraft slid to a halt, largely intact. Wehrmacht forces reached it before destruction could come, and within hours it had been transported eastward, away from the advancing front to Rechlin. Tierfelder's orders were unambiguous. Assess the aircraft's performance, catalog its strengths and weaknesses, and determine whether the frontline reports were accurate or exaggerated. Find something German pilots could exploit. He climbed onto the wing and slid into the cockpit. The seat position struck him immediately higher than in any German fighter he had flown, offering unparalleled visibility. The canopy was a single bubble of curved plexiglass, uninterrupted by the heavy frames that limited vision in a Messerschmitt Bf 109. Here, one could see nearly everything. The instrument panel stretched before him, labeled in English, with small paper strips translating each gauge into German. Manifold pressure, fuel mixture, coolant temperature. Every control was within effortless reach. American ergonomics, he mused. They designed for the pilot, not the other way around. He examined the throttle quadrant. The throttle itself sat on the left, a departure from the German standard on the right, but it felt surprisingly natural. Beneath it were the mixture control and propeller pitch lever. The Mustang used a constant speed propeller, automatically adjusting blade angle to maintain optimal RPM. Another piece of American philosophy: automate what can be automated, so the pilot can focus on the fight. The technical specifications were already meticulously documented by Rechlin's engineers. The Packard V1650-7 engine, essentially a license-built Rolls-Royce Merlin 61, delivered 1,490 horsepower at war emergency power with water methanol injection. Its two-stage, two-speed supercharger maintained performance at altitudes where German engines faltered. The propeller was a Hamilton Standard 4-blade, 11 feet across. Empty weight, 7,040 pounds. Maximum takeoff weight, 12,100 pounds with full fuel and ammunition. Add 2 external drop tanks, and the aircraft exceeded 14,000 pounds. Yet reports claimed it remained remarkably agile. Its armament was simple but effective. 6 50-caliber Browning M2 machine guns, 3 in each wing. No cannons, unlike German fighters. The Americans gambled on rate of fire over hitting power, a cone of bullets through which any enemy aircraft had to pass. Luftwaffe pilots reported that, in practice, the Mustang's guns were devastating, especially in deflection shooting. Tierfelder signaled to the ground crew, "Chocks in position, fire extinguisher ready." No one knew if this American engine would start reliably on German fuel and under German maintenance routines. The Merlin was notoriously temperamental, requiring high-octane gasoline that Germany could no longer produce in sufficient quantity. For this test, they relied on captured American fuel from stockpiled dumps in France. Following the translated startup procedure, he enriched the fuel mixture, cracked the throttle an inch, set magnetos to both, and pressed the starter. The engine turned over once, twice, then roared to life. The 4-blade propeller spun into an almost invisible disc. The Merlin's sound filled the air, a deep, smooth rumble, a world apart from the harsh mechanical snarl of a Daimler-Benz DB605. It was precision. It was finesse. The British had designed it as a racing engine in the 1930s before adapting it for the Spitfire. The Americans had perfected production, building tens of thousands, powering the Mustang, the Spitfire, even the mighty Lancaster bomber. Imagine standing on the tarmac at Rechlin, the wind biting at your cheeks, the scent of fuel and oil heavy in the air. The aircraft before you hums with restrained power, yet there is an almost imperceptible promise of something extraordinary. For Tierfelder, this moment carries an uneasy truth. He has spent his life steeped in the legend of German engineering supremacy. From childhood, he has been fed the intoxicating narrative that German technology is unmatched, that every machine that bears the Reich stamp is the pinnacle of human ingenuity. Propaganda has spent years cultivating this image, and the early triumphs of 1940 and 1941 seem to validate it. Tanks tearing across Poland and France, the Luftwaffe shattering enemy air forces, and even the Royal Air Force forced into a reluctant stalemate over Britain, at least according to the official story. Yet as 1944 unfolds, a different reality presses itself upon him. The Luftwaffe is hemorrhaging pilots at a rate no training program can match. Factories spew out Messerschmitts and Focke-Wulfs in quantities unprecedented, yet the skies of Germany seem ever more hostile. The bottleneck is not production, it is quality, both of machine and man. American pilots arrive over the Reich with 200 to 300 hours of flight experience. German replacements, barely seasoned, get 30 to 50. The planes the Americans fly almost defy the known laws of aeronautical engineering. German fighters, for all their refinement, remain evolutionary iterations of 1939 designs, clever but fundamentally outdated. He climbs into the cockpit of the Mustang, the tailwheel linked to the rudder pedals offering him precise control on the ground. Visibility over the nose is good, better than the cramped forward view of a Bf-109, though not quite the panoramic vision of a Focke-Wulf 190. He performs his pre-takeoff ritual with practiced precision. Controls free and correct, trim tabs set, fuel on the main tank, mixture rich, propeller full forward, flaps up. American doctrine eschews flaps for ordinary takeoffs, relying on the wing's natural lift. The tower clears him. He taxis onto the runway, aligns with the center line, and pushes the throttle forward. The Merlin engine roars to life with immediate authority, pressing him back into the seat. The tail rises, offering a sudden clarity of the world ahead. The speed climbs 100, 150, 200 kilometers per hour. At 220, he gently eases back on the stick, and the Mustang lifts gracefully into the sky. A mere 400 meters of takeoff roll. A Focke-Wulf requires 600. Already advantages claimed. Gear up, the mechanical thunks of landing gear folding into the wings echo around him, and then the revelation. Acceleration unlike anything he has ever felt. No drag to fight. No laboring to convert power into speed. Just a surge forward. 250. 300. 350 kilometers per hour. At barely 500 meters, he's already faster than most German fighters at their top speeds. Over Brandenburg, he climbs 2,500 meters, testing the controls. The ailerons are light yet decisive, the elevator smooth and progressive, the rudder effortless. The engine's torque balanced. This plane is designed for the pilot as much as for combat long hours. Minimal fatigue. Systems that serve the pilot rather than demand constant correction. At 3,000 meters, he levels off, methodically testing turns, banks, climbs. The Mustang, oh boys. Predictable, stable, almost boringly so. But that stability is its lethal advantage. Then he opens the throttle fully, nudges the stick forward, and the acceleration is breathtaking. 350, 400, 450, 500, 650 kilometers per hour. At 4,500 meters, the airspeed hits 715 kilometers an hour, roughly 440 km/h. He has flown the Focke-Wulf 190 A8, one of Germany's finest, topping at 653 kilometers. The Bf-109G maxes out near 621 kilometers. The Mustang is not marginally superior. It rewrites the equation. 60 kilometers per hour difference means the German pilot cannot dictate the fight. Engagements happen on the American pilot's terms. He pushes into a climb, war emergency power engaged, water methanol injection feeding the supercharger. The Merlin roars, 1,490 horsepower pushing him skyward. German fighters falter above 5,000 meters. The Mustang climbs effortlessly, 7,000, 8,000 meters. He is now in the thin, cold stratosphere where Messerschmitts struggle and Focke-Wulfs strain. The Mustang feels at home. Controls crisp, engine steady. 10,000 meters, still climbing over 4 meters per second. It could go higher, surely, if pressed. Here, the combat reports make sense. American bombers fly at 7,000, 8,000 meters, where flak is less lethal and oxygen-starved German pilots falter. Mustang escorts patrol even higher, diving onto Luftwaffe interceptors from advantageous altitudes. The fight is never fair. It was never intended to be. At 8,000 meters, Tierfelder begins maneuverability tests, rolls, climbing turns, reversals. Every movement is precise, responsive. He expects weaknesses. Long-range fighters often sacrifice agility for endurance. Spitfires turn beautifully but are fuel-limited. P-47, Thunderbolts are heavy hitters, not nimble. Yet the Mustang turns with authority, outclassing expectations, even at altitude. He documents every response. Slow flight stable, stall benign and recoverable, high speed handling controlled, predictable. No flutter, no surprise vibrations. Controls grow heavier, but remain intuitive, preventing overreaction at extreme speeds. And now, the ultimate test, the one that will reveal what this aircraft is truly capable of. High-speed diving. For German pilots, it was always a dangerous dance. The Luftwaffe's fighters had a fraught relationship with the dive attack. The Bf-109 in particular harbored a hidden terror: compressibility. As the aircraft neared the speed of sound lower at altitude because of the frigid air, the airflow over wings and control surfaces would hit transonic speeds. Shock waves formed, controls stiffened, then locked entirely. A plane could tumble toward the earth uncontrollably. Recovery was impossible until either the dive shallowed at lower altitudes, where the speed of sound increased, or the aircraft tore itself apart under aerodynamic stress. Luftwaffe pilots had perished this way. Training drilled a simple maxim: engage, attack, but never follow a diving enemy beyond safe velocity limits. Tierfelder tilted the Mustang's nose downward, 15 degrees below the horizon. 20. 30. He advanced the throttle, urging the aircraft into the dive. The airspeed needle climbed, 500 kilometers per hour. 550. 600. The fighter remained perfectly stable, tracking straight as an arrow toward the earth. 45 degrees. The patchwork fields of Brandenburg grew larger in the windscreen, roads and villages stitching the landscape together. 750. 800 kilometers per hour. Still, the Mustang answered every input, ailerons and elevator functioning smoothly, the controls resisting pressure but never faltering. No buffeting, no structural warnings, no sense of impending catastrophe. At over 800 kilometers per hour, nearly 500 miles per hour, the dive felt controlled, almost routine. Tierfelder pulled back sharply. The nose rose immediately. G-forces pressed him into the seat. 3, 4 Gs, his vision graying at the edges. The dive flattened, transitioned to level flight, then climbed. Speed bled off rapidly, converted to altitude, and the Mustang settled at 4,000 meters, unscathed and obedient. The tactical implications struck him like a physical blow. Any Luftwaffe pilot attempting to escape a Mustang by diving would not escape. The P-51 could follow, remain controllable at speeds where German fighters became unresponsive, and still retain the power to climb afterward. There was no safe escape vector, save perhaps a daring low-level dash, but even that was doubtful, given the Mustang's unmatched visibility and handling. Every tactical lever German pilots had relied upon for 4 years, speed, altitude, diving attacks, was neutralized by a single aircraft design. Descending back toward Rechlin, Tierfelder throttled back, conserving fuel. 40 minutes of aggressive flight testing, including multiple climbs and high-speed dives, left nearly 70% of internal fuel intact. The Mustang's fuel management was extraordinary. 1,100 pounds in internal tanks, roughly 170 gallons, plus 2 110-gallon external drop tanks, totaling 390 gallons. This granted a combat radius of approximately 750 miles. From England to Berlin, almost 600 miles escort bombers, engage in combat, and return. The Mustang could do it all. No German fighter could make that claim. The Bf-109G, combat radius 200 miles. The FW-190A, roughly 320 with a drop tank. German fighters were tethered to their bases. Scramble, climb, intercept, return to refuel. The Americans had no such constraint. They could linger over German territory, persistent, omnipresent, an unyielding threat. The strategic ramifications were devastating. Tierfelder entered the landing pattern at Rechlin. Power reduced, landing gear extended. The Mustang decelerated smoothly. Flaps down, a slight nose dip required back pressure on the stick. Over the threshold, throttle, idle, gentle back pressure. The main wheels kissed the concrete, tail settled, the aircraft rolling out straight and true. 47 minutes of flight. 47 minutes that would forever change his understanding of air combat. As he taxied to the dispersal area, ground crew and engineers waiting, he shut down the Merlin. its whine wound down into silence. Now came the task of organizing his thoughts. The report must be precise, technical, and unflinching. Luftwaffe High Command needed truth, not comforting illusions. But beyond the numbers and data, there was something more profound. He had flown an aircraft that invalidated every assumption German doctrine held about long-range fighter design. The Rechlin facility had tested, captured Allied aircraft since the war began. Early Soviet fighters were crude, but effective. British Spitfires impressed, but lacked range. American P-47 Thunderbolts were powerful, but heavy. Each had exploitable weaknesses. The P-51D Mustang? Strength in every category, no obvious flaws. Faster than German fighters at all altitudes. Superior climb above 6,000 meters. Better diving characteristics at all speeds. Adequate turning for combat. Exceptional range, making German fighters look like trainers. Unmatched visibility, reliable systems, an engine delivering smooth, predictable power. And perhaps the most psychologically shattering truth. This was not a handcrafted rarity. It was mass-produced by semi-skilled workers in American factories, thousands rolling off assembly lines, in numbers German industry could never match. Over the next 3 days, Tierfelder and his team compiled their formal evaluation. Methodical, organized, damning. Performance summary: maximum speed at 4,500 meters, 715 km service ceiling, 12,770 meters. Rate of climb at sea level, 16.3 ms combat radius with drop tanks, 102 10-km endurance at cruise power, Fort Fent comparative analysis, Voivod's Focke-Wulf, 190A contournate, faster at all altitudes, better climb above 6,000 meters, superior dive, triple the combat radius, FW, 190, retains roll rate advantage at low altitude, heavier cannon armament. Overall, Mustang superior in most combat scenarios, versus Messerschmitt Bf-101G6, faster at all altitudes, better climb above 5,000 m, significantly better dive. Triple the combat radius. Bf-109 retains low-altitude turn rate advantage, comparable armament. Overall, Mustang superior in most combat scenarios. Tactical implications. The P-51D redefines fighter design. German doctrine emphasized heavy armament, robust construction, and performance optimized for typical European combat altitudes, 3,000–6,000 meters. The Mustang's advantage came from aerodynamic efficiency, a finely matched engine and airframe, and revolutionary laminar flow wings reducing drag. Its range enabled it to escort American heavy bombers anywhere in German-controlled territory. Luftwaffe pilots could no longer rely on bombers turning back from fuel limits. The escorts never returned. The report included exhaustive technical appendices, photographs of the laminar flow wing, supercharger system analysis, fuel management documentation, armament installation details. Every element meticulously recorded. Every detail a testament to the aircraft that had just redefined the air war. Picture German engineers in the cramped, fluorescent-lit halls of their research facilities, poring over every blueprint, every rivet, every contour of the captured Mustang. They measure, photograph, calculate, desperate for a thread of insight that might be applied to the Luftwaffe's own faltering designs. Yet beneath the meticulous notes and technical schematics lies a bitter, unspoken truth, one no report dares to pronounce aloud. Even if Germany could duplicate the Mustang down to the last bolt tomorrow, the nation lacks the industrial muscle, the raw materials, and the time to produce such machines in any quantity that might matter. The Packard Merlin engine at the Mustang's heart demands high-octane fuel, a substance Germany cannot synthesize in sufficient amounts. Allied bombing has already crippled synthetic fuel production, and by the autumn of 1944, German fighters will be grounded, not because of an absence of planes, but because of the fuel to fly them. The Mustang's airframe itself relies on advanced aluminum alloys, materials that Germany can only produce at enormous cost or import under increasingly impossible circumstances. Meanwhile, American factories churn out Mustangs in numbers that make German production look almost trivial. A single Mustang requires roughly 1,000 hours of labor, yet the United States produces over 400 per month. German output, heroic in effort, cannot keep pace with the attrition of frontline units. And even if the Reich could miraculously replicate the aircraft, there is another, starker barrier: pilots. Luftwaffe training programs have collapsed under the dual pressures of fuel shortages and the relentless drain of war. Replacement pilots are thrown into combat after merely 30 to 50 hours of flight time. The Americans, in contrast, provide 200 to 300 hours, much of it in aircraft closely resembling what will be flown in combat. The result is more than a technological advantage. It is a systemic one. The United States is winning not just the aircraft war, but the industrial war, the resource war, and the pilot training war, simultaneously, decisively, and irreversibly. Tierfelder's report, once typed and stamped, climbs the labyrinthine ladder of Luftwaffe bureaucracy. It passes through the hands of staff officers, tacticians, and doctrine planners. It is read, noted, and ultimately filed, consigned to the archives. Yet the document cannot alter reality. By July 1944, the Luftwaffe is locked in a defensive struggle it cannot hope to win. The Normandy invasion succeeds, despite German opposition. Allied fighters and bombers roam the skies over the Reich with growing impunity. The Luftwaffe's intricate network of radar stations, ground controllers, and regional fighter wings is being systematically dismantled under the weight of overwhelming force. Rechlin's test flight merely confirms what operational statistics already reveal. In July 1944 alone, the Luftwaffe lost roughly 450 fighter pilots, killed, missing, or captured. The training system cannot replenish these losses. American losses, though significant, are mitigated by a training pipeline that produces pilots faster than they are lost. German losses, in contrast, outpace training by a critical margin. The Mustang is not just a superior fighter, it is the embodiment of American industrial, technological, and organizational dominance. It demonstrates that the United States can design, manufacture, and field a system surpassing German capabilities, and do so at a scale that renders German output almost negligible. On 25 July 1944, 5 days after Tierfelder's initial flight, another pilot repeats the test to verify the findings. The results are identical. The Mustang performs as predicted, flawless, with no hidden weakness. For months, the aircraft remains at Rechlin, occasionally flown, continuously studied. Engineers document every detail, analyze every dimension. Yet despite their expertise, they cannot replicate it with the resources and time remaining. By October 1944, Allied forces have liberated France and approached Germany's western borders. Rechlin, once deep in secure territory, now lies within range of Allied reconnaissance flights. The captured aircraft, Mustang included, must be evacuated or destroyed to prevent recapture. Its precise fate is lost to history, possibly abandoned on a dispersal pad, destroyed during air raids, or scrapped as Soviet forces approached Brandenburg in spring 1945. Werner Tierfelder survives the war. Captured by American forces in May 1945, he spends months in a prisoner of war camp before release. In post-war interviews, debriefed by Allied intelligence, he speaks candidly. When asked about the P-51 Mustang, his response is unequivocal. It was the finest all-around fighter of the war, superior to the Focke-Wulf 190, the Messerschmitt Bf 109, and even, in most practical combat scenarios, Germany's jet-powered Me-2 and Me-2. Reliable, plentiful, and capable of being flown competently by moderately trained pilots, it was an aircraft that redefined air combat. For a man steeped in the mythology of German technical supremacy, this admission could not have been easy. Yet Tierfelder was, above all, a test pilot, rigorous, honest, unflinching in reporting what he observed. 47 minutes in the cockpit of the Mustang were enough to reveal truths that no propaganda could conceal. This episode is more than an anecdote of performance statistics. It is a collision between ideology and engineering reality, between the narrative of supremacy and measurable fact. The Third Reich's identity was tightly entwined with claims of technological preeminence. German engineering was portrayed as inherently superior, a reflection of racial and cultural genius. Early successes seemed to validate this myth. Bf-109s dominated over Poland and France. Luftwaffe doctrine, innovative and precise, maximized the aircraft's potential. But cracks appeared in the Battle of Britain. The Supermarine Spitfire proved a worthy adversary, sometimes surpassing the Bf-109 in handling. German losses mounted unsustainably, and the planned invasion of Britain faltered. Subsequent upgrades, the Bf-109G, the Focke-Wulf 190, improved performance, but the opposition evolved. The Soviet Union flooded the skies with effective, mass-produced aircraft, while the United States brought unparalleled industrial capacity and technical refinement. By 1943-1944, American fighters were not merely numerous, they were often superior in speed, altitude, handling, and reliability. The P-51 Mustang represents the apex of this evolution. A synthesis of British aerodynamic research, Rolls-Royce Merlin engine design, American mass production expertise, and operational experience, it was conceived to meet precise requirements for long-range escort. North American aviation began design in 1940 for British needs. The prototype flew just 120 days later. Early Mustangs with Allison engines excelled at low altitude, but lacked high-altitude performance. The Merlin retrofit transformed the aircraft, granting it speed and power at all altitudes, and establishing it as not just fast, but a game-changing force in the skies. The P-51B had first taken to the skies in December 1942, immediately demonstrating performance that outstripped anything then in service. By the time the P-51D arrived, with its bubble canopy and increased ammunition capacity, the design had been refined into something even more formidable. When Tierfelder flew the captured example at Rechlin in mid-1944, the Mustang was rolling off American assembly lines at a staggering rate, over 400 aircraft per month. By war's end, total P-51 production would surpass 15,000, almost equal to the combined output of all Focke-Wulf 190 variants across the entire conflict. This industrial capacity was itself a weapon. Even when German pilots achieved favorable kill ratios in individual engagements, and by late 1944, they often did. The arithmetic of attrition favored the Allies overwhelmingly. The Americans could lose aircraft and replace them within weeks. The Germans could not. Yet the captured Mustang forced test pilots to confront something far more uncomfortable than simple numerical disadvantage. They had to acknowledge that this American fighter was not only more numerous, it was objectively superior. Better in ways that could be measured, timed, calculated, felt through the control stick, and verified without dispute. The Mustang was faster check the stopwatch. It climbed better at high altitude measure with altimeter and timer. It had longer range compute from fuel consumption. It handled beautifully feel it in the stick. Every evaluation, every test, every objective measure pointed to the same conclusion. The Americans had out-engineered Germany. This contradicted everything German ideology purported to believe. According to Nazi propaganda, Americans were culturally inferior, weakened by democracy and racial diversity. How, then, could a nation considered racially impure produce an aircraft superior to that of the disciplined, orderly Reich? For staunch believers, The cognitive dissonance must have been crushing. For pragmatists like Tierfelder, the evidence was simply evidence, uncomfortable perhaps, but undeniable. The Rechlin flights were not unique. Several P-51s had been forced down or captured intact during the war, each one studied rigorously. The conclusions were always the same. In one account, a Luftwaffe pilot who had flown both the Bf-10I-9 and a captured Mustang likened the comparison to that of a Volkswagen and a Mercedes. Perhaps unfair to the Messerschmitt, which had been exceptional in 1939, but by 1944, the Bf-10I-9 was an upgraded design constrained by its pre-war configuration. The Mustang, by contrast, was a clean sheet design. No legacy compromises, no outdated assumptions, optimized for long-range escort missions. German engineers were particularly fascinated by the Mustang's laminar flow wing. Developed by NACA, the U.S. National Advisory Committee for Aeronautics, it maintained smooth airflow over more of the wing surface, dramatically reducing drag. German designers understood the theory, but in practice, they had never implemented it successfully in production. Achieving the necessary manufacturing tolerances was extraordinarily difficult. Any surface imperfections, protruding rivets, or rough paint could ruin the effect. Yet American production accomplished this consistently, at scale. The wing was a triumph not just of design, but of industrial process control. This principle extended to the aircraft's other systems. The Packard Merlin engine was not inherently superior to German designs and concept, but American quality control guaranteed each engine met specifications reliably. German engines of the same era exhibited significant variation, some exceptional, others barely adequate. The Americans delivered consistency. The Mustang's fuel system was equally impressive, multiple fuselage and wing tanks, plus external drop tanks, paired with a sophisticated management system, allowing pilots to maintain proper balance throughout flight. The tanks were self-sealing, lined with rubber that swelled when punctured, minimizing catastrophic fuel loss. German fighters had similar systems, but the American implementation was more robust. Even the sheer amount of fuel the Mustang carried, while retaining top performance, revealed a level of design integration Germany could not match under wartime constraints. Small details spoke volumes. The cockpit layout was logical and uncluttered. The gun sight was simple and effective. The radio reliable and easy to use. The landing gear robust and tolerant of rough fields. These seemingly minor elements collectively separated a great fighter from a merely good one. German aircraft often excelled in raw performance, but suffered reliability issues, maintenance challenges, or idiosyncrasies that made them difficult to operate. The Bf-10I-9's narrow landing gear, for example, led to more pilot losses on the ground than in combat. The FW-190's radial engine was powerful but temperamental, requiring careful management to avoid overheating. The Mustang, by contrast, was a pilot's airplane, forgiving, reliable, effective across a wide range of scenarios. By autumn 1944, the Mustang had achieved what German planners had once deemed impossible: air superiority over Germany itself. American fighters patrolled German skies with near impunity. When Luftwaffe aircraft managed to take off despite chronic fuel shortages, they were hunted relentlessly by Mustangs, capable of outperforming them in almost every situation. Germany's response became increasingly desperate. The Messerschmitt Me-262 jet, finally entering service in significant numbers in autumn 1944, could exceed 850 km/h, faster than any propeller-driven fighter. It was a technological leap. But it arrived too late, in too few numbers, approximately 1/400 aircraft. Many never flew combat missions due to fuel shortages, lack of trained pilots, or Allied bombing of airfields. The jet engines themselves were temperamental, with service lives measured in hours, not the hundreds achievable by a Merlin engine. The Me-262 required long concrete runways, leaving it vulnerable during takeoff and landing, when Allied fighters could exploit its brief periods of disadvantage. Even if Germany could have produced the Me-262 in unlimited numbers and perfect reliability, the strategic situation would remain unchanged. The war was not lost because German fighters were too slow. It was lost because of fuel shortages, lack of trained pilots, industrial limitations, and shrinking defensible territory. Allied aircraft were not just winning aerial engagements. They were systematically destroying the infrastructure necessary for German resistance. Heavy bombers, escorted by Mustangs, obliterated synthetic fuel plants. By early 1945, hundreds of Luftwaffe fighters sat grounded, engines silent, pilots walking away because there was simply no fuel to fly. The irony was stark. Germany had invested enormous resources in perfecting fighters. The Bf 109 continuously upgraded, the FW 190 refined, the revolutionary Me-262 developed, countless experimental designs pursued. The Americans had taken a different path: build a good fighter, mass produce it, and use it to enable strategic bombing that destroyed the enemy's ability to fight. The Mustang was not the fastest, nor the tightest turning, nor the most technologically advanced fighter of the war. The Mi-262 was faster. The Yak-3 turned better at low altitude. The Spitfire Mark IX had handling advantages. But the Mustang was the most effective, a combination of excellent enough performance, reliability, range, and most crucially production numbers that allowed a strategic impact no single advanced German fighter could achieve. The lesson extended far beyond World War II aviation. Victories in technology are not won by pursuing the highest performance alone. They are won by creating systems that achieve sufficient performance, can be produced at scale, maintained reliably, and employed effectively in the field. Germany had pursued perfection in individual aircraft design. The Americans had pursued victory through integration, scale, and practicality. And the Mustang was the embodiment of that strategy. Imagine the captured Mustang sitting on the tarmac at Rechlin, painted with Luftwaffe crosses, yet fundamentally, undeniably American. When Tierfelder landed it after 47 minutes of rigorous test flying, he carried knowledge the German High Command desperately needed and feared. The combat reports had been correct. The Mustang was exceptional. Likely better than field reports suggested, because those reports were always tainted by confusion, fear, and incomplete observation. Test flights offered clarity, objective, clinical, irrefutable. But knowledge alone does not change outcomes. The Luftwaffe could not replicate the Mustang's design, nor train enough pilots to fly the fighters it already had. Fuel was insufficient to keep the aircraft airborne, and industrial facilities were under relentless bombardment. Even armed with the truth, the Reich lacked the means to respond. Knowing defeat was coming was no shield against it. The captured Mustang became a symbol, a silent testament to the chasm between German assumptions and Allied reality. The paint and markings mattered little. The performance remained untouchable. It was what it was: proof of American industrial and technological supremacy. In the decades since, historians and engineers have studied the Mustang extensively. The verdict is unanimous. The P-51D was arguably the most consequential Allied fighter in the European theater. Its introduction in significant numbers in early 1944 coincided directly with the collapse of effective Luftwaffe resistance. This was no coincidence. The Mustang enabled the strategic bombing campaign that shattered German industry. It achieved air superiority over the Reich, allowing Allied ground operations in France, and later Germany itself, to proceed with minimal interference from German aircraft. It forced the Luftwaffe into an unbreakable defensive posture, all while being fundamentally simpler and more economical to produce than many German fighters. Consider the economics. The Mustang required roughly 25,000 man-hours to manufacture. A Focke-Wulf 190 required only 13,000. Yet the Mustang's capabilities far exceeded the German aircraft, offering a vastly higher return on investment. Factor in superior reliability and longer service life, and the advantage becomes overwhelming. This dimension economic efficiency is often overlooked in discussions of military technology, yet it was decisive. Wars are not won solely by the best equipment. They are won by the side that can produce good enough equipment to sustain operations while denying the enemy the capacity to do the same. The Mustang combined quality with quantity, achieving air superiority at a scale Germany could never match. For the German test pilots at Rechlin, this lesson was immediate, visceral, unavoidable. The intellectual realization that Germany was losing the air war became a physical experience in the cockpit, through the control stick of an enemy aircraft that outperformed their own. Werner Tierfelder continued flying and evaluating German designs in the war's final months, training pilots and testing aircraft. But by early 1945, these efforts were largely academic. Fuel was scarce, pilots were fewer, and there was no realistic prospect of reversing Germany's fortunes through aviation technology. He witnessed the evacuation of Rechlin as Soviet forces advanced, the painstakingly maintained facility, the captured aircraft collection, all abandoned or destroyed to prevent capture. The Mustang he had flown vanished in the chaos, likely destroyed in place or reduced to scrap. After the war, Tierfelder took part in debriefings with Allied intelligence, contributing to a remarkable body of technical literature. Freed from the ideological constraints of the Nazi period, pilots and engineers spoke candidly. The consensus was striking. Across every metric of performance, the P-51D Mustang was the finest all-around fighter of World War II. Some German pilots noted niche advantages of specific aircraft. Certain Focke-Wulf 190 D9s dived faster, the Me-262 outran everything in level flight, and the Bf-109K4 climbed best at very low altitudes. But no plane could match the Mustang's performance across the spectrum of speed, altitude, range, maneuverability, and operational practicality. For men trained to believe in German aviation's inherent superiority, this was a profound reversal. They had begun the war convinced that German engineering was beyond reproach. They ended it acknowledging that an American aircraft, conceived in 1940, refined over several years, and produced in vast numbers, had surpassed everything Germany fielded. The psychological journey from unquestioned national pride to reluctant acknowledgement of foreign mastery must have been disorienting. Yet for test pilots like Tierfelder, where objective measurement outweighed ideology, the evidence was incontrovertible.